So our today's topic is building a binary tree from given traversing. And the second topic is threaded binary tree. In the last lecture, we discussed about the different traversing methods like pre-order traversing, in-order traversing, and post-order traversing. So I assume that you all are aware about all these three methods of traversing a binary tree. So now suppose we have the any two traversing uh, of the binary tree, and then we want to find out the actual binary tree of that binary tree. These are the traversing. And the next topic we will discuss how we can thread the binary tree, and that is known as threading. So in that topic also we will use these traversing methods. So before joining this session, you should firstly see the previous lecture. So now these are the traversing mechanism I have discussed. In the last lecture, I talked about this algebraic expressions also and the observation. Now, suppose we have in-order traversing and pre-order traversing of a binary tree. So this traversing we have, and now the purpose is we want to find out that actually binary tree. We know that in pre-order traversing, the root of the binary tree, the root of the binary tree will be at first position. In post-order traversing, the root of the binary tree will be at last position. So this is the point you should note. In pre-order traversal, first element is the root of the binary tree. Okay. Now, in-order traversal, first element is the leftmost element of that binary tree. And in post-order traversal, the last element is the root of the binary tree. So we will use these observation. So in pre-order traversal, you can see that the first element 50 will be the root of that binary tree. So we can write 50 as a root of the binary tree. And suppose we are assuming that this T1 is the left subtree and T2 is the right subtree of that binary tree. So 50 become root, this T1 is the left subtree and this T2 is the right subtree. Now, for this T1, now we are concentrating on this T1. So for this T1, again we will find out the in-order traversal and pre-order traversal. So you can see in in-order traversal, we know that 50 is, the root node. 50 is the root node. So here in 50, you can see in in-order traversal, this is 50. So you know that in in-order traversal, firstly left subtree will be traversed in order, then root, and then right subtree will be traversed in order, because it is in order traversing. So before 50, this will be the in order traversing of this T1. So we can write here 50 30, 35, 40, 45. This is the left subtree T1's in order traversing. Similarly, we got the element of the left subtree T1. So in similarly, you can see in pre-order this 30, 15, 40, 35 and 45. These five elements will be the pre-order traversal of this T1. So we got the pre-order and in-order traversing of T1. So again, by applying same observation, this 30 will become the root. This 30 will become the root of this T1. So 30 becomes root of T1. And now this 30 come in order traversing. This 30 we have in order traversing, and before that we have just one element. So definitely it will be the left child. So we can write 15 as a left child, and then it will give this T1 dash. Suppose we are assuming T1 dash. So in order traversing of this T1 dash is this one, and pre-order traversing of T1 is this one. So again, I have written here 35, 40, 45 is in order traversing, and 40, 35, 45 is the pre-order traversing of T1 dash. Now again, by pre-order traversing, this 40 will become root. Come here, take this 40 in order traversing. So after this 40 we have 45, and before 40 we have 35. So definitely 35 is the left child and 45 is the right child of this 40 node. So we got this T1 dash. So we can return back to this T1 and putting this value of T1 dash. So we got this T1 as 30, 15, then 40, 35 and 45. And now again returning back to this tree T, this T1 will be replaced and it will become 50, and this left subtree here, and T2 dash, sorry, T2 same. Now similarly, just like we got this left subtree of the root node, we can do same process for T2 as well. So now this T2, we are applying same concept in order traversing and pre-order traversing we got here. So this 70 will become the root node. This 70 will become the root node of the T2. So 70 become root. Again, take this 70 in order traversing. So we can see here before 70 we have only one node, that is 60. So definitely it will become the left child. And after that it will become the right child, right subtree. So this, suppose we assume T2 dash, so it will become the in order traversing of T2 dash. And again for T2 dash, this is the in order traversing. हमने इसको लिखा यहाँ पे 77, 75, again this one. And then pre-order traversing, this is the root, this is the left subtree, so remaining are the right subtree. So this is the pre-order traversing of T2 dash. Now again, first element will become the root, so 80 will become the root of T2 dash. Now 80 we are keeping here, So before that we have 3 node, but after 80 there are no node. That means right subtree is empty. So all the node will be in the left subtree. So suppose this is the left subtree and we are assuming that this is T2 double dash. So this is the in order traversing of T2 double dash, and the pre-order traversing is this one. Again 75 will become the root. So 75 we are keeping this value here. So before 75 we have 72, after 75 we have 77, then definitely 72 will become left child and it is right child. So this is T2 dash. So returning back to T2 dash, this tree will be completed. So now it becomes this one. This is now T2 dash. Now again returning back to T2, here we'll get this right subtree, and then after returning back to original tree we will get this binary tree. So you can see by just keeping these 2 points we can find out the actual binary tree. Now the next topic we have threading. Specifically, we will replace certain null entries by special pointers which points to node higher in the tree. What happens? We know that if in a binary tree, if the left subtree or right subtree is empty, then if we consider the linked list implementation, then the pointer which will points to left subtree or right subtree, we keep null if the subtrees are empty. So the in concept of threading, basically we replace these null pointers. In concept of threading, basically we replace these null pointer, and after the replacement of these null pointer, these pointer we say threads, and after threading the binary tree we call threaded binary tree. So we replace certain null entries by special pointers which points to nodes higher in the tree. हम जो नल पॉइंटर्स हैं उनको रिप्लेस करेंगे उन पॉइंटर से जो पॉइंट करेंगे उन नोड्स को जो बाइनरी ट्री में हायर पोजीशन पे होंगे, और इन पॉइंटर्स को वी विल कॉल थ्रेड्स, and binary tree with such pointers are known as threaded tree, या sometime we say threaded binary tree. And in diagram, threads are usually indicated by dotted lines. If we implement in memory, then we can have one extra bit for tag field for that purpose. Now, so there may be several ways for the threading. So there are many ways to thread a binary tree, but each threading will corresponds to a particular traversal of the binary tree. So there are several ways, but each way will correspond to some traversing. So suppose we are, you may choose anyone, but suppose we are having this in order traversal. Again, there are two ways. One is known as one-way threading, another one is two-way threading. In one-way threading, a thread will appear in the right field of node and will points to the next node in order traversal. Again, I remind you, I have selected in order traversing here. That's why I have written in order traversal. If there are another traversing is used for threading, then there will be that traversal. So we selected in order traversal. So thread will appear in the right field of node and will points to next node in the in order traversal. In two-way traversing, thread will also appear in left field of node and will points to the preceding node in the in order traversal. In one way will points to the next node. In two way, the right one will point same as we have in one way threading, but here we will have left thread also, which will point to the preceding node. So it will be clear more in example. So see here, this is one way threading. Suppose this is the binary tree we have. So you all are aware about the traversing of this one. I have already discussed. So you know that in order traversal, root will be traversed after left subtree. So after D in your traversal, the next node will be B. So this D node have no left child or right child. So its right pointer will be a null pointer. So if we thread this binary tree, so this right pointer will be replaced by a thread that is a pointer which will points to the next node in order traversal of this binary tree. So this right pointer will point to B. Similarly, according to in order traversal, after F, E will come. So F, right pointer of F will points to E, and so on. After E, A, after G, C, after L, J, after J, H. So mind it, we will replace null pointer of that node which have right pointer as a null. So this is one way threading. Here we are just replacing right pointer only. In two-way threading, we will replace left pointer as well. So in this figure A, we are just adding left thread also, and it will become two-way in order threading. So here F left pointer is also empty. So it will point to the B. So F pointing B. Why? Because in order traversing before F, it will come B. Similarly, before G, A will come. So left pointer will point this A. Again, L will point C. K will point to H. You may have a question in your mind that why not the right pointer of K and why not the left pointer of D? You know that in order traversing before D we have no node. So that's why we have no option to replace. Similarly, after K we have no node in traversing. So that's why it will be null pointer. So this is all about the today's discussion. In next lecture, I will discuss the Hoffman coding. Thank you.